Hi, welcome to Train Signal. Welcome to the continuation of the Advanced Services for Server 2012 course. We're exploring Active Directory replication in this section. We're exploring configuring the idea of sites, laying out the physical topology of our network so that the users in our network are able to access resources that are relatively nearby them. Hang on, the phone's ringing. 1 second. Global Metrics Help Desk, this is Mike. Yeah, and you're located in which office? New York City. Okay. Logins are how slow? Really? Okay. And that's all the time, or just intermittently? So sometimes it's fast, sometimes it's slow? Okay. All right. Let me put in a ticket for this. I will call you back as soon as we find a solution. Yep. Thanks for calling. Okay. So just got a call here at the Global Metrics Help Desk. Somebody having authentication issues. Logins are taking an awfully long time sometimes, but really quick other times. And my suspicion is that perhaps we've misconfigured our replication, our site topology inside of our network, so that data to be able to get a login processed is flowing in less than optimal ways. Active Directory relies upon a mental picture of what the network looks like. Here's the map of what things look like here in our Global Metrics office. We've got our corporate New York City headquarters. We've got a major office in Dallas, 2 smaller offices out in Chicago and Louisville, Kentucky. We've got various WAN connections tying those together, some as fast as our nice fat T3 line running between New York City and Dallas, other offices connected with less speedy connections all the way down to Louisville, dangling on the other end of a 56K dial-up connection. Poor souls. So, I've got a user in New York City trying to get logged in. Sometimes they get a fast login, sometimes they get a slow login. They're not quite sure why. Let's try to explore what's going on here. This is the network that we're working with. These are our physical networks, our physical links that connect them, our IP address ranges that are in use in those networks. How come when a user is trying to get logged in, sometimes they're getting a fast connection, sometimes a slow connection? Well, that's all driven by the speed of connection between themselves and the domain controller that they're authenticating against. If that connection is fast, they'll get a fast login. If it's a slow connection, they'll get a slow login. So what drives that connection to a domain controller? Some of you are familiar with Active Directory from our other courses in which we explore AD functionality in finer detail, and might recall that one of the central components of making Active Directory work is the DNS, Domain Name System functionality, in which I'm able to let a client computer call a domain controller and request a list of domain controllers that are relatively nearby it in the network. And DNS knows that information somehow, automatically. And with that information, the client contacts that nearby domain controller and gets authenticated. So something seems to be breaking down in that process. We need to kind of figure out what that is and why. So what we need to do is to make sure that we've explained to Active Directory correctly which sites, which subnets reside in our network. What areas of physical networking do we have in our company? How are they connected? Which IP address ranges live where? Our main tool for that is a tool called Active Directory Sites and Services, in which we start by defining what's our network like, which IP address ranges are in use. Having identified that, we can logically describe which physical areas of high-speed, high-reliability networking we have in our organization by defining sites. We define exactly which named areas of networking are in use in our organization. We can then identify which kinds of network links tie together those sites. A site is an area of high-speed, high-reliability networking. Consider a local area network where everybody's connected through some set of nearby switches, maybe a router or two. But in general, everybody's relatively nearby each other, connected together by a relatively high-speed connection. LAN speeds, 100 megabits per second, gigabit per second, something like that, something fast. Site links are therefore the relatively slow connections that link together our network into a larger wide area network. Having laid out the description of what our network physically is like, our remaining issue deals with configuring replication by making sure that our domain controllers, our Active Directory DCs, know which physical part of the network they are associated with. So that when a client says, hey, find me a DC near me, they actually get the list of DCs that are near them and not one that's on the other side of the country. So we're going to explore those functionalities as part of this lesson here, touching also on the idea of something called bridgeheads. Let me jump to the GUI and let's take a look at how our network is currently configured and see if we can figure out why our user is having a hard time. So here I am on New York City Server 1. I want to do some Active Directory troubleshooting, figure out why my user's getting sporadic login times. I'm going to jump to my Tools menu and open up the tool called Active Directory Sites and Services. Sites and Services helps me define the list of physical areas where networking occurs, the ranges of IP address in use in those locations, which domain controllers are located in which areas, things of that sort. And there's my tool, inside of which we see a container for sites. Inside my sites container, I want to draw your attention first to this area here, default first site name. Now, when Microsoft's engineers first designed Active Directory, and they realized that they had this idea of defining sites, note that pre-Active Directory, Microsoft didn't have a mechanism for this. NT4 had no physical description of the physical topology of my network. In Active Directory, I can define a site, and indeed I must define a site. In order for me to have Active Directory, I've got at least one domain controller. That domain controller must live somewhere. It's in some physical network with some range of IP addresses. Therefore, there will always be at least one site, otherwise we wouldn't have Active Directory. So Microsoft wanted to be able to give that first site a name. And not knowing where you would set up your first domain controller, they gave it a default name. They called it default first site name. Catchy, huh? Creative engineers. What we want to do for practical purposes probably is to rename this. And I can do that at will. Whenever it seems sensible to change the name of that, let me make this New York City. Now it's going to holler at me here because it doesn't like having spaces in the name, so let me trim out the spaces and cut it back down to New York City. There we go, I have a New York City site. Inside of that New York City site, I've got a container labeled servers. Now, servers in this context has a very specific meaning. It doesn't mean member servers. It doesn't mean workgroup servers that happen to be in that location. What it means is domain controllers. And I've gone ahead and deployed 3 domain controllers in the Global Mantics network. I've got one living in the Chicago office, I've got one in the Dallas office, one in the New York City office. So New York City server 1, Dallas server 2, Chicago server 3. And those are scattered all over the country. They're connected, as you're aware, with slow network connections. There's a T1 between New York City and Chicago. There's a T3 between New York City and Dallas. 128K ISDN line lies between Dallas and Chicago. So we've got a network that's got 3 domain controllers. They're networked together over relatively slow connections by comparison to the speed of the network that networks that are tied together with that connection. Inside of that list of domain controllers contain something called an NTDS settings object, which identifies from which other domain controllers these domain controllers will be getting their configuration settings. Domain controllers that are part of the same domain talk with each other. They replicate data back and forth. And in this case, Chicago replicates data from Dallas and New York City. The Dallas server replicates from Chicago and New York. The New York server replicates from Dallas and Chicago. Note that the column here is labeled from server. Now, how did those get there? Well, we'll talk about that in a bit. First, I want you to be aware that at the moment, as far as Active Directory is concerned, there is one site, one location in the world, and it's New York City. Now, what does that mean? That means that if a user sitting in New York calls DNS, says, hey, I need a list of domain controllers that I can authenticate against that are nearby me, DNS is going to be relying upon this information that we've configured through this Active Directory Sites and Services tool and say, yeah, here's a local server. It's called Dallas Server 2. Here's a local server for you. It's called Chicago Server 3. Well, if the client is in New York City and they get told to authenticate against a domain controller in Chicago, they're crossing a T1 line to be able to get that authentication done instead of using the gigabit network that we've got set up in New York City. That's not terribly good. So there's our problem. This is why my user's having a hard time. The user wants to be able to get authenticated from a local domain controller, and Active Directory is badly misinformed about the actual physical layout of our network. So what do we do about that? Well, let's build a couple more sites. Let me build a site that describes the Dallas office. Whenever I build a new site, I need to associate it with something called a site link. I'll develop that idea a little bit more carefully in a moment, so hold that thought for the site links. It's told me that I've built my site. It invites me to add subnets to the Dallas subnets container and to install a domain controller in Dallas or move an existing DC there. Well, we've already done that. That DC is already in Dallas. The problem is that Active Directory isn't aware that it's in Dallas. So that's something that I will do. I'm going to move the existing DC into that site by right-clicking Dallas Server 2 and moving it into Dallas. Did it work? It did. Let me build a site object for Chicago. I need to choose an IP site link to go with it. I've only got one to choose from. Did that work? At the moment, there's nothing in the service container because I haven't moved it yet. Let me move Chicago Server 3 into the Chicago site. So that's a step in the right direction. Next question, though, is how does a given client know what site they're in? That's all driven by IP address configuration. When a client computer calls a DNS server, it knows its IP address, it knows the domain that it's part of, and that's about it. The DNS server is going to refer the client to any nearby domain controller to query to find out what site it's part of. And that's a mapping between the client's IP address and which subnet objects configured here are associated with which sites. So let me build some subnet objects for the purposes of supporting those clients who want to be able to connect to a local resource and have only the mechanism of their local IP address to know where they're physically at. I'm going to create a 192.168.50.0/24 network in Chicago, because that's the range of IP addresses that we use there. A client computer will now be able to call a domain controller, say, hey, my IP address is 192.168.50.17. Do you know where I am? And that domain controller can say, ah, yes, you're in the Chicago location. The client says, oh, I'm in Chicago. Oh, that's great. And can now call DNS, say, hi, not only am I a member of the globalmantics.local domain, but I'm in the Chicago site. Now which domain controller should I authenticate against? There are a number of other site-aware applications in the Microsoft universe. DFS, the distributed file system, is site-aware. The tool called Microsoft Exchange has site-aware functionality to it. So there's a number of ways in which we can take advantage of that capability. I'm going to create another subnet here, 192.168.50.0/24, Class C network. That goes in our Louisville office. But something interesting here. I don't have a Louisville site object. Now, why not? In this case, I didn't choose to build one. You'll recall that in my slide we had Louisville there. And that's because I've only got 4 employees working out of our little Louisville branch office. I'm not going to put a domain controller there. In which case, what I'll probably do is associate that subnet with the Dallas site. Dallas is the nearest neighboring site to Louisville. It's connected by that slow dial-up line. But that is the closest location of a domain controller. Computers in the .55 subnet should probably think of themselves as if they're in Dallas, because that will be where they will go to get the resources that they need. Let's build a subnet for the New York City office. New York City in our network uses the 10.79.anything.anything Class B network range. We got a lot of people there. And Dallas proper uses the 172.23.everything.everything Class B network, plus the .24 and the .25 in that same 172 range. So let me go ahead and build those. 172.25.anything.anything/16, 16 bits in the subnet mask in Dallas. So there we go. My subnets have a IP address range and an association with a particular physical site description. Those sites contain a domain controller. So now when my client in New York City boots up his computer, that computer is going to go call DNS, say, hey, I'm looking for domain controllers for globalmantics. Can you help me find one? The DNS server says, yeah, here's a bunch of them. That client calls, actually technically it calls all the domain controllers. It sends out a bind request to every DC the DNS describes. The client then tries to find the one that's nearby it by responding to whichever one returns a reply soonest. It's going to call that computer and say, hey, my IP address is 10.79.82.45. Which site am I in? And Active Directory will consult this piece of information right here to determine that that client is in the New York City site. The client then goes and calls DNS again. Says, hey, I'm part of the globalmantics.local domain, and I just learned I'm in the New York City site. Now which domain controller should I talk to? And that request is going to go hit only the servers that appear in the New York City site. And there's only one server in the New York City site. It's New York City Server 1. That's where the authentication request is going to go. So you can see it's vitally important that we configure our sites to be able to describe exactly where our resources are located. If I've not adequately defined which sites are out there, it's possible that a client might inadvertently try to get connected to a resource that's not anywhere near them. As far as they're aware, that domain controller is right next door. Our next important piece of configuration that is part of this Active Directory Sites and Services tool is the configuration of inter-site transports. A transport is effectively a description of a protocol over which communication can go from one site to another, from Dallas to Chicago, from Chicago to New York City, etc. Two technologies that provide that ability, IP and SMTP. SMTP, you'll recall, is used for email. SMTP is Simple Mail Transfer Protocol. It's used to be able to get email between Exchange servers or similar sorts of email servers. IP, of course, is used for all sorts of purposes. SMTP is used in some rare cases in Active Directory. I don't think I've ever seen it deployed in a production environment that I've had any interaction with, but it's neat to know that it's there. There are some limitations to it. It does require digital certificate-based security on top of that communication to make sure that we're sending that data securely. There's a number of challenges with using it. It's not able to replicate the main partition of the AD database, the so-called default naming context partition. That won't replicate over SMTP. So we're going to use IP for almost all practical purposes. Inside of which, there's the default IP site link. What does that mean? This site link claims to be a logical connection that links those three sites together, almost as if we had like a frame relay network or something that maps multiple networks together through a shared network connection. In this case, I don't have anything like that. So really, default IP site link isn't really an accurate description of anything in my network. So what I can do is destroy it, if it'll let me, and it does. I'm now going to build appropriate site links that actually describe the connectivity between the sites in my network. So let's build a site link, for example, that describes the connection between New York City and Chicago. So I've got at present a T1 line from New York City to Chicago. What sites are in this site link? Well, New York City is in this link, and so is Chicago. This is a link that links together New York City and Chicago. Again, there are networking technologies that will knit together more than two network locations into a broader link. In this case, this particular site link describes the T1 that links just those two sites together into a connection. Okay, and let me build one for New York City to Dallas. We're connecting that with a T3 line. T3s have a connection speed of approximately 45 megabits per second. That's connecting New York City to Dallas. And we're going to need a link that describes our 128K ISDN line from Dallas to Chicago. So what's in that link? Dallas and Chicago are in that link. New York City is not. 128K. There we go. So there's our three site links. But, again, they're not all the same, are they? The T3 line, 45 megabits per second. The T1 is a mere 1.544 megabits per second, about 30 times slower than the T3. The ISDN line is 128 kilobits per second. It's a couple orders of magnitude slower than the T1. So how do I tell Active Directory the relationship between those links? Because if I want to get data from one site to another, if I've got a site-aware application that can't find a local copy of the application that it wants to connect to, it'll have to reach out over my site links to get to the other site where these resources reside. If that's true, then I want to make sure that we're taking the shortest path to what might be multiple copies of that network available resource. So how do we accomplish that? What we're going to do is define for each of these site links something called a cost. The cost is an abstract number that represents approximate network speed, approximate descriptions of availability of that link, things along those lines. Bandwidth will certainly be the primary driver of our cost. Cost here might actually be a financial cost if I pay by the bit for certain kinds of connections. Really, it abstractly represents how hard it is organizationally for me to get data from one side of that link to the other. Well, in the case of the 45 megabit per second T3 line, that's a really nice fast connection. There's a lot of bandwidth available to us there. I would prefer to use this over just about anything else. So what I'm going to do for that is I'm going to set a cost number that is relatively low. Setting a low cost number is a way of saying that that is a high priority link. I want to use that one if I've got the choice. So let's use that as our baseline, 100. The number in the cost box can range anywhere from 1 on the low end to 99,999 on the high end. So it's quite a range of numbers. Higher means less desirable, lower means more desirable. So if my T3, 45 megabits per second, is a cost of 100, well, what's the cost of my T1 line, 1.544 megabits per second? Well, it's something like 30 times slower. So my cost, in a perfectly abstract world, could easily be something 30 times larger. So let me make it 30 times bigger than it was a moment ago, to 3,000. How about my ISDN line? ISDN line is 128 kilobits per second. That's 10 times slower again. So let's take that up to a cost of 30,000. 10 times slower, roughly, than my T1 line. So what does that mean? That now means that in the case where data needs to get from Chicago to New York City, of course it'll take the T1 line because it's much shorter than taking the ISDN line over to Dallas, even though we'd then be taking a nice fast 45 megabit per second connection back up to New York. Data going from Dallas to Chicago, it's got its choice of taking a 128K link at a cost of 30,000, or a choice of going over the T1 line to New York City, and then from New York City across the T1 line at a cost of 3,000 over to Chicago. Data replicating from Dallas to Chicago will almost certainly prefer to go through New York City to get there because it'll be faster. So costs provide a really nice way for Active Directory to be told by an administrator, and this is all manually defined. I would love to see an addition to this in Windows Server 2017 that will dynamically detect the bandwidth on your network and configure these numbers for you, but unfortunately doesn't do that by default. With that information configured correctly, my network now runs more smoothly. My client computers are able to authenticate against a neighboring domain controller instead of one that's far away, and my domain controllers can replicate with each other smoothly over the available set of network connections that they can take advantage of. So let me jump back over to my slides for a moment and we'll see what we can do with this network now that we've got it established. So now that we've got Active Directory sites and services configured correctly, that puts the wheels in motion for two major components of Active Directory that are going to be helping support our Active Directory replication behavior. We saw the benefits, of course, to authentication, but what about domain controller management proper? Domain controllers need to replicate data amongst one another. I've got 3 domain controllers. They're all part of the globalmantics.local domain. I want changes that I make on one domain controller to get to all the other DCs, the other 2 in this case. I got 1 per site. The KCC, the Knowledge Consistency Checker, does work inside of an Active Directory site. It looks at all the available domain controllers that are in that neighboring location and will attempt to construct the optimal set of logical links between those domain controllers. If I've got a long list of domain controllers, I don't necessarily need every domain controller to talk to every other domain controller to make sure they're all in sync. And as long as all of them talk to at least somebody, everybody should be able to get synchronized with updated information in a reasonably adequate period of time. And the KCC, once every 15 minutes, recalculates the topology inside of a local site to figure out which domain controllers we're using and which domain controllers should talk to each other to get data replicated around inside of that site. The other key component of Active Directory that's relevant here is something called the ISTG, Inter-Site Topology Generator. This tool has a very similar function, but applies that idea more broadly within my network. The ISTG's job is to build logical connections between domain controllers between sites, from one site to another. So if I've got multiple domain controllers in Chicago and multiple domain controllers in New York City, which ones are going to replicate with each other across that connection. And the ISTG's main job is determining the bridgehead servers. Because we're crossing a slow link there, we don't really want every DC or even most of the DCs on each of those two sites replicating directly with each other. What I would rather do is replicate just between one domain controller in Chicago with one domain controller in New York City, and then let all the other New York City and Chicago DCs replicate amongst one another to learn the changes that came from those other sites. This way I can have a Active Directory administrator presence in both cities. People make changes as need be. Those changes get to everywhere that they need to go. So it's that functionality that is driving some of the configuration that we saw in our Active Directory Sites and Services tool. Let me jump back over there for a moment. So back here in my Server 1 domain controller, I can see that each of my servers is described by something called an NTDS settings object. That name NTDS is an old one. That's NT Directory Services. That's the name of the old NT4 environment. Why Active Directory has an NTDS settings object, we'd have to fly to Redmond and talk to a Microsoft developer to find out. But what's important to note is that that container is a container for two, at the moment, automatically generated connection objects. We can see that New York City Server 1 is preparing to replicate data from Dallas Server 2 and Chicago Server 3. And again, remember that the servers containers here contain domain controllers. They don't contain member servers, they don't contain standalone workgroup servers, they contain domain controllers. And the NYC Server 1 domain controller wants to replicate data from the DC called Dallas Server 2 and the one called Chicago Server 3. Meanwhile, Server 2 is replicating from, at the moment, Server 3. Server 3 in Chicago is replicating from Dallas Server 2 and New York City Server 1. The KCC, the Knowledge Consistency Checker Service, is periodically reevaluating this list of connections, trying to figure out which connections are the optimal ones to be able to get our environment working properly. In a busy, active network, the KCC will be every 15 minutes recalculating the topology to determine the optimal set of these connection objects to be able to replicate data amongst my domain controllers most efficiently. In this case, I can't see from this tool which connections were built by the KCC or by the ISTG. In this case, because all my domain controllers are all in different sites, we can reasonably guess that those connections were built by the ISTG, the Inter-Site Topology Generator. It is possible to build your own. Just at the moment, Dallas is replicating just from Server 3. Let me hit my F5 refresh to see if there's been any changes. Nope. But it's not replicating at present from New York City. I can build my own custom connection for that purpose if I choose to. I can right-click, build a new Active Directory Domain Services connection, and it wants to know from which domain controller do I want to replicate. And I want to be able to replicate data in perhaps from the one place I'm not replicating from currently, which is to say New York. So I'll choose New York from my list, click OK. Wants a name for that connection. If you're building your own manual connection, it might not be a bad idea to put your own signature on it to make sure that somebody can come track you down and say, hey, why did you build that connection? Oh, well, when I was there, I didn't see a connection to New York City. I wanted to make sure we were replicating from New York City, so I decided to do that. Because that connection is there, the KCC, the Knowledge Consistency Checker, will now begin recalculating its work next time it does a recalculation, taking that manually created connection into account. So it'll assume that that's important, because if it wasn't, an administrator wouldn't have put it in, and will build all of its other connections flowing around that piece of information. This is something that you might do in a case where you've got some specific application, you know that certain kinds of changes are going to be made in a specific city, you want that data to be available fairly quickly in some other city where another part of that application resides. I can deliberately make sure that there's a direct connection between two particular sites by building a connection object that links a domain controller in each of those two sites. While we're in this area, there's one other important idea that I want to address that relates to site configurations. Let me jump back over to my slide to be able to illustrate that idea. So while we're talking about replication, there's one other important idea that I want to address before we bring this lesson to a close, and that's the idea of sysvol replication. Sysvol is a folder of data that lives on every domain controller, and among other jobs, it's the home of all of your group policy settings. If you build a GPO, you build a group policy object, part of that data lives in the Active Directory database itself, something called the GPC, the group policy container. But what that GPC does not contain is the list of the actual settings being deployed to clients. That data lives in this sysvol folder. And by default, it's replicated from one DC to another using something called NTFRS, NT File Replication Services. Microsoft back in the Server 2008 era set up an opportunity for us to use a command line tool called DFSR MIG, DFSR migration, to be able to change to the use of DFSR instead of NTFRS to replicate that sysvol content from one domain controller to the other. So when I make a change to a domain controller, that data gets to the other DCs quickly and efficiently. DFSR relies on a technology called RDC, Remote Differential Compression, the intent of which is to replicate a file from one spot to another, but doing so by replicating just the changes of a file from one spot to the other. Other earlier technologies in NTFRS will replicate a whole file from one spot to another. But RDC is smart enough to be able to take the content that changed from a file, replicate that across the network, plug it into the other copy of the file. It's a great idea. This is going to be an improvement to the performance of replication of the sysvol. DFSR has some good troubleshooting tools that gives us better insight into what's happening in that replication as opposed to NTFRS. So there's lots of good reasons to want to be able to make that upgrade. Something worth looking into. It's a phased process. I moved through a series of phases of turning on support for DFSR-based replication of sysvol in a way that I can easily back out of if something goes wrong. So while that's not a huge consideration, it is one that you may want to put on your research project list as a potential upgrade for the future. I hope this information about configuring replication has been helpful to you in your Active Directory environment, and I look forward to sharing more information with you in the next lesson.